Good afternoon. Today I am going to talk about large scale sterilization. In case of sterilization, we have covered different methods of sterilization. So sterilization is a process of killing the microorganisms by which an article, that may be any glassware or any pharmaceutical preparations, are made free from microorganisms. So there are various methods of sterilization that we have already covered. So the next point regarding sterilization is large scale sterilization. There is the difference between laboratory scale and large scale sterilization. Laboratory scale sterilization involves the equipments which are of smaller size, and the large scale sterilization involves the use of equipments which are of larger size. In pharmaceutical industries, the production of parenteral preparations goes on, and those parenteral preparations are produced into the huge quantities, and for that purpose the small scale equipments cannot be used because it will consume too much time, and for that purpose the larger equipments, the equipment which are larger in size, which are very huge in size, so these kind of equipments can be used for production as well as processing within the pharmaceutical areas or pharmaceutical operations in which the manufacturing is mainly carried out. So the sterilization methods are divided into two types, that is physical methods and chemical methods, that we already know. The dried sterilization involves hot air oven, moist air sterilization involves autoclave, then filtration is there, radiation sterilization. The chemical methods involves the use of various gases as well as disinfectants. So these methods we have already covered. So the equipments which are used for large scale sterilization are steam sterilizer, dry heat sterilizer, ETO sterilizer, that is ethylene oxide sterilizer, then sterilizing tunnel, then CIP system and SIP system. So all these equipments can be used for large scale. The sterilizer indicates that it is the equipment which is used for the sterilization purpose. First one is steam sterilizer. This equipment sterilizes the waste or materials by exposing it to the steam under high pressure, thereby making it free from any contaminants. The moist heat sterilization mainly utilizes the steam under pressure, which is very efficient agent to kill the microorganisms. We already discussed into the topic of autoclave that the pressure is applied to the steam. The steam is heated. The steam has high penetration power as compared to dry heat, and that's why it is one of the efficient agent to kill the microorganisms. So manufacturers can design customized sterilizers to suit the needs of individual clients, and the capacity varies depending upon the size of the plant. Yes, according to our need, we can select the suitable size of the particular equipment, and on the basis of that, the manufacturer of the steam sterilizer designs that particular equipment or steam sterilizer. A widely used equipment for steam sterilization is the autoclave, that we already know. So autoclaves are commonly used equipments for pharmaceutical sterilization. So these use steam heated at 121 degrees Celsius at 15 psi pressure. Okay, so 121 degrees Celsius temperature and 15 psi pressure is generally used conditions in case of autoclave. So heat in the form of saturated steam under pressure is the most practical and dependable agent for sterilization. The laboratory apparatus used to design steam under pressure is called as Autoclave. Saturated steam is more efficient sterilizing agent than hot air because it provides greater killing action of moist heat. It is quicker in heating up the exposed articles and it can penetrate easily porous materials and many more. Okay, so the laboratory autoclave is the simple autoclave that we already know. Again, I will repeat, it mainly consists of cylinder which is made up of stainless steel. The lid means cover is fastened by screw clamps and it is made airtight by asbestos gasket. The autoclave has on its lid or upper side a discharge tap for air and steam, a pressure gauge which indicates the pressure, and safety valve that can be set to blow off any desired pressure. So it is the laboratory autoclave. But if you see the large scale autoclave which has different construction as compared to laboratory autoclave. So the it is the steam sterilizer. It is the cost effective solution to sterilize the medical waste as well as infectious waste as well as various pharmaceutical, chemical and food and beverages. Okay. It is the equipment which does not helps to eliminate the problem of environmental pollution by doing away with methods like incineration, but also helps to minimize and eliminate the expense of disposing of untreated medical waste. The sterilizing equipment sterilizes the materials by exposing it to steam under high pressure, thereby making it free from any contaminants. Okay. So this sterilizer uses the temperature of 121 degrees Celsius and as well as pressure, that is 15 psi. So it can be used to sterilize the items, but as the heat takes much longer to be transferred to the organism, both the time and temperature must usually be increased unless forced ventilation of hot air is used. Dry heat as the not dry heat. So the moist heat or a large scale autoclave, its construction is made up of stainless steel, okay, or iron. Then the lid, we can say door, is fitted with the clamps and asbestos jacket. Then it is the stationary autoclave, maybe double doors at both ends, one for loading and one for unloading. So the large scale autoclave is the stationary autoclave, means which cannot be moved from one place to another place, while the laboratory autoclave can be moved from one place to another place according to our requirement. So it has the two doors. One door can be used for loading the materials and another door is used for unloading the materials. Then there is the pressure gauge. Of course, there is the pressure gauge which indicates the pressure. Let's see, onto the right side of the large scale autoclave there is a control panel with which we can set the required temperature as well as pressure, and there is the digital display which indicates the temperature as well as the pressure inside the autoclave. Then there are the thermocouples which are mainly used for measurement of the temperature, which are placed inside the autoclave. Then there is an air vent to remove the air before sterilization. So whatever air is present before sterilization process starts, that's to be removed out from the sterilization, from the sterilizer, and air vent has been there from which we can remove the air. Then safety valve is there which permits the escape of excess steam to prevent the explosion. So steam under pressure is produced within the larger chamber, and that steam can explode if it is not removed at various time intervals, and for that purpose the safety valve is there. Okay. Then modern autoclaves are recording they are recording pressure as well as temperature during the whole process. They are mainly supplied with timer. They are automatically controlled. So this machine, this equipment is automatically controlled. Only we have to set up the required temperature and pressure, okay, and we have to load the materials which we want to sterilize and switch on the equipments. So whatever glasswares or materials are there, they are automatically sterilized. Okay, and at the end of sterilization process, the equipment gives the alarm, and after that it automatically switches off. Okay, so likewise it is the fully automated equipment mainly used for sterilization purpose. Then next sterilizer is dry heat sterilizer. Okay, it mainly uses the dry heat for sterilization purposes that we already covered. So a widely used equipment for dry heat sterilization is the hot air oven. A standard setting for hot air oven is at least 2 hours at 160 degrees Celsius temperature. So the difference between autoclave and the hot air oven is that the autoclave utilizes lower temperature as compared to hot air oven, and autoclave requires less time as compared to hot air oven. So as the temperature required is higher, so the materials which are heat sensitive cannot be sterilized with the help of hot air oven. So a rapid method heats the air to 190 degrees Celsius for 5 minutes for unwrapped objects and 12 minutes for wrapped objects. We already discussed that whatever material we want to sterilize into the autoclave as well as into the hot air oven, they must be wrapped. Okay, so wrapping with the help of newspaper as well as aluminum foil or other materials can be done, so that the materials are not directly exposed to the sterilizing agent. Dry heat has the advantage that it can be used on powders and other heat stable items that are adversely affected by the steam. Yes, powders and oils cannot be sterilized with the help of autoclave because they are affected in presence of moisture, and that's why such materials can be sterilized with the help of dry heat sterilizer. So here it is the simple laboratory hot air oven that we have already known, that we already discussed. So it is the very smaller apparatus or device. Here we can see it is the large scale hot air oven within which we can enter. We can put up the materials and we can switch on the equipment and we can close the doors. So likewise, with these very huge equipments and huge size of the materials or large quantity of pharmaceuticals can be processed within this large scale hot air oven. So the process is fully automated. We have to set the required temperature, okay, load the materials, close the doors, and the sterilization is mainly carried on. At the end of sterilization process, the alarm blows and equipment automatically switches off. Okay, so after means the cooling is also automatically carried out after the end of sterilization process. Okay, so after cooling is over, we can open the door and unload the materials from the hot air oven. Okay, so likewise the dry heat sterilization as well as hot air oven is also one of the widely used method of sterilization within pharmaceutical industries. So here you can see there is the door which is fitted with clamps as well as asbestos jacket, which is having single door. Okay, then there is a regulator which regulates or controls the temperature. Then there is a fan attached inside for air circulation and perforated shelf for keeping the objects inside. So perforated shelves means these are the places on which we have to keep the materials. These are perforated means which are having holes so that air circulation is mainly easy. So whatever dry air is there, that will be exposed to all the materials placed onto the perforated shelves. Then the next one is ETO Sterilizer, that is ethylene oxide sterilizer. So ethylene oxide sterilizer are most widely used into the pharmaceutical industries and healthcare institutions to sterilize products which are sensitive to moisture as well as heat. So ethylene oxide is one of the gas that we already discussed. So that is a kind of gaseous sterilization. So these high technology sterilizers are potent in killing pathogens and consist of electrical heating jackets and provides excellent steam and temperature distribution into the heating chamber. The heating chamber is generally made up of stainless steel and enclosed with aluminum or stainless steel panels. The machines are also equipped with automatic temperature control mechanism. Here into the figure you can see which is the larger equipment. The machinery is too much complicated. An effective ETO process can be properly designed for almost every type of medical device, and permeable packaging configuration provided that all variables are assessed through process design and development. Typically, the ethylene oxide process can be broken down into 4 basic phases. Okay, these are air removal, then steam injection, and then ethylene oxide injection and gas purge. Okay, so pre-sterilization conditioning involves the pre-sterilization conditioning, the use of sealing and evacuating the chamber and adjusting the temperature and pressure of the chamber. Then actual sterilization is carried out, which involves addition of ethylene oxide as a sterilant and maintains an optimum operating pressure and temperature into the chamber. Then evacuation and air washing. This process involves evacuating the chamber and giving it a number of air washing to remove any trace of ethylene oxide gas, and then aeration. Finally, any residue of ethylene oxide into the product or material is removed through the aeration, which can either be done into the chamber or in a specially designed aeration chamber. Okay, so likewise the process of ethylene oxide sterilization is carried out. Then next one is sterilizing tunnel. So tunnel is a passageway from which the materials are conveyed from one place to another place. So sterilizing tunnel is mainly used in pharmaceuticals, chemicals, petrochemicals, as well as into the food industries. Sterilizing tunnel is a tunnel like region responsible for dry heat sterilization and depyrogenation of containers, vials, bottles, as well as ampoules. The containers are sent to the sterilizing tunnel through a conveyor belt and sterilized with the help of heated air flow, which is generated by means of fan as well as heater. Here you can see it is the large equipment, okay, which is the sterilizing tunnel, which is having doors as well as there is a control panel. Inside it there is the diagrammatic representation of sterilizing tunnel, which is having 3 zones, that is preheating zone, then heating zone, and then cooling zone. Preheating zone mainly consists of stainless steel mesh transport belt. Okay, there are the provisions for loading as well as unloading the materials. So this belt carries the materials from preheating zone through heating zone to cooling zone. Inside the heating zone, there are temperature sensors as well as heaters, which are mainly responsible for dry heat sterilization. Then into the cooling zone, there is air supply with the help of HEPA filter. So all the air supply is mainly carried out with the help of laminar airflow. And finally, the materials which are sterilized are unloaded from the tunnel. So likewise, the airflow can be controlled by adapting the RPM of the fan during the heating phase. So it is also one of the generally used equipment mainly for sterilization of vials, ampoules, as well as for bottles. Then next large scale sterilization system is clean in place, that is CIP system. Clean in place or CIP systems are widely used in the pharmaceutical and biotechnology industry to clean and decontaminate the tanks, reactors, pumps and transfer lines. Actually, this system is mainly used for cleaning purpose, but decontamination or mechanical removal of microorganisms can be done with the help of this system. The heating can be used for killing the microorganisms. Okay, so the variables of temperature, pressure, chemical concentration, exposure time are controlled by the CIP system skid. CIP system skid is the control panel given onto this system, which mainly automatically controls all the variables. Here onto the image you can see these are the larger chambers are there, which are having the piping system that is mainly connected to the control panel, and onto the control panel we can control all the variables like temperature, pressure, chemical concentration as well as exposure time, so that all the parameters could be set. This system is automatically controlled. Okay, so cleaning in place is most widely used, which mainly starts with proper selection of all the parameters to deliver the required cleaning parameters to the intended targets. The variables are set, then it ensures improved hygiene and sanitize more effectively than manual cleaning. Then next system is sterilization in place, that is SIP. Sterilization in place refers to the sterilization of production equipment without prior disassembly. Sterilization is usually carried out by means of superheated steam. SIP systems are used in areas where germ reduction plays an important role or decisive role. Sterilization is carried out with steam at 120 degrees Celsius and 15 psi pressure over a period of about 60 to 70 minutes. The duration varies according to application and system type. The CIP and SIP system work automatically to meet the most stringent hygiene regulations, demand as well as the quality. So SIP and CIP systems are widely used in case of pharmaceutical industries to maintain the high conditions of hygienes as well as the quality within the pharmaceutical industries, so that the cleaning process as well as the dosing system can be carried out very effectively. Okay, so this is all about the large scale sterilization. So all these systems are mainly used for sterilization purposes at large scale. So these equipments handling requires the skilled operators, so that the materials can be handled very effectively as well as the process of sterilization can be completed very effectively. Okay, thank you.